Okay, here we have question 9. You're going to first tell if the segment AB is tangent to the circle of C. First, you have to notice that the segment of AB is tangent to triangle ABC if it's a right triangle. What is true is a squared plus b squared is equal to c squared, then ABC is a right triangle. So all you have to prove is a squared plus b squared equals to c squared. So plug in the values. A is 9, B is 15, C is the longest side, which is 18. Okay, left-hand side is 306, and right-hand side is 324. They're not equal. Therefore, line segment AB is not tangent to circle C. For it to be tangent, a squared plus b squared has to be equal to c squared, because that angle at the point of tangency has to be 90 degrees. Therefore, that has to be a right triangle that is created. Question B. Point B is a point of tangency. That means a squared plus b squared exists. It's possible because it's a right triangle. When triangle ABC is a right triangle, a squared plus b squared has to be equal to c squared. Okay? Because it was given. Point B is a point of tangency. Plug in the values. A could be equals to 9. B equals to R. C is actually R plus 6. It's the entire length segment. Okay? Be careful. 9 squared is 81. R squared is R squared. But R plus 6 squared, you have to multiply the binomials. R squared plus 12R plus 36. Okay? Do some algebra. I'm going to minus cancel R squares on both sides. They both cancel out. 81 equals to 12R plus 36. Minus 36 to both sides. You get 45 equals to 12R. Divide by 12. R is equal to 3.5.